Bismillahirrahmanirrahim. In this lecture, we have to discuss review of differentiation. First, we have to explain uh, rules of differentiations. Then we have to discuss this rule uh, for functions. Then there are many functions: trigonometric functions, inverse trigonometric functions, hyperbolic functions, and so on. First, we have to discuss rules of differentiations. So, in rules, first one is constant rule. Means derivative of constant must be zero. Example for this is derivative of 5 is equal to 0. Derivative of 5 is equal to 0 because pi is constant. Then uh, derivative of constant multiple rule. Constant multiple rule means derivative of c of f of x must be equal to c f dash of x. Example for this is the derivative of 5x square is equal to 5 times derivative of x square. Here we used uh, constant multiple rules. Derivative of uh, some rules. Some rules is used when two functions are given in the form of sum or difference. So derivative of f of x plus or minus g of x is equal to derivative of f plus or minus derivative of g. Product rules. Product rules are used when two functions uh, are in the form of product. Uh, derivative of uh, f and g is equal to derivative of uh, derivative of f derivative of g plus g derivative of f. Quotient rule. Quotient rule is used when two functions in the form of quotient. So this is equal to derivative of f divided by g is equal to g square in the denominator. G square in the denominator. G of x derivative of f of x minus f derivative of g. Change rule. Change rule is equal to change rule uh, is used when function in this form derivative of f of g of x is equal to f dash of g of x and again derivative of g. For example, uh, derivative of uh, sine x square is equal to derivative of uh, sine is equal to cos n x square. Again derivative of x square. Here f function is sin x and g function will be x square. So uh, here in this derivative, we used change rule. Power rules. Uh, Power rule is equal to derivative of x square is equal to n x power n will be equal to n time derivative of x power n minus 1. For example, derivative of x power 10 is equal to 10 times x power 10 minus 1. So, uh, derivative of x power 10 will be equal to uh, 10 times x power 9. Now we want to discuss derivative of trigonometric functions. So first one, derivative of sine will be equal to cos x. Derivative of cos is equal to minus sine x. Derivative of tangent is equal to secant square x. Derivative of uh, derivative of cotangent is equal to minus cosecant square x. Derivative of secant will be equal to secant x tangent x. Derivative of secant is equal to minus time cosecant into cotangent. Now derivative of inverse trigonometric functions. Derivative of uh, sine inverse x is equal to 1 over square root 1 minus x square. Derivative of uh, cos inverse x is equal to minus time 1 over 1 minus x square. So a derivative of sine in cos differ only by negative sign. Derivative of tangent inverse x is equal to 1 over 1 plus x square. Now derivative of cotangent is equal to negative time 1 over 1 plus x square. Derivative of secant inverse x is equal to 1 over x absolute time square root x square minus 1. Derivative of cosecant derivative of cosecant inverse x is equal to 1 over minus time minus time 1 over x square root x square minus 1. So we see that derivative of secant and cosecant are differ by negative sign. Also derivative of uh, tangent and cotangent uh, differ only by negative sign. So the only difference is negative sign. Derivative of hyperbolic uh, function. Derivative of hyperbolic function. Derivative of sine hyperbolic is cos hyperbolic. Derivative of cos hyperbolic is sine hyperbolic x. Derivative of tangent hyperbolic is equal to secant hyperbolic square x. Derivative of cotangent x is equal to minus time cosecant square cosecant hyperbolic square x, and derivative of uh, secant hyperbolic x is equal to minus time secant hyperbolic x into cotangent hyperbolic x. Derivative of uh, cosecant hyperbolic x is equal to minus time cosecant hyperbolic x and cotangent hyperbolic x. Uh, Derivative of inverse trigonometric functions. Inverse hyperbolic function. Derivative of secant secant hyperbolic inverse x is equal to 1 over square root x square plus 1. Derivative of cosecant hyperbolic inverse x is equal to 1 over x square minus 1. Derivative of tangent hyperbolic inverse x is equal to 1 over 1 minus x square. Similarly, derivative of cotangent hyperbolic inverse x is equal to 1 over 1 minus x square. Derivative of secant hyperbolic inverse x is equal to 1 over x times square root 1 minus x square. Derivative of secant hyperbolic inverse x is equal to 1 minus time 1 over x it's a root time square root x square plus 1. Now derivative of exponential function. Derivative of natural log x is equal to uh, natural log x is equal to 1 over x. Also derivative of log x to the base a is equal to 1 over x time natural log x. So uh, means that derivative of uh, derivative of derivative of natural log x is equal to 1 over x and derivative of uh, e power x is equal to e power x again. Similarly, derivative of log x to the base a is equal to 1 over x natural log x. Similarly, derivative of a power x is equal to a power x natural log a natural log a. So this means that if given that uh, derivative of uh, tangent inverse e power x is equal to what? So this is equal. This is equal to. This is equal to uh, 1 over 1 plus e power x whole square. So this can be written as 1 over 1 plus e power 2x. So derivative of tangent inverse e power x is equal to 1, 1 over 1 plus e power 2x. Thank you so much for watching this video. Please subscribe the channel.